Hello everybody. Alright, so we're going to continue some notes on integrals that yield inverse trig. Or do they? Alright, just to be clear, we kind of stopped at different places and I jumped around and I kind of mixed a couple things up. So, if you are in period 4, perfect, you got lucky. I'm going to use your notebook and continue from there. If you are in period 2, you actually are in pretty good shape because the one I'm about to do, you already have done. You guys actually got the farthest. But we lost a little bit of time. 6th period. Don't worry, you're still special to me. You guys are off by 1 as well, so you're going to hear me talk about a question. So basically fill in what you don't have. Let's just do that. So let's see here. Let me start by explaining my example 5 from period 4, and that means my period 6, you guys are going to copy that down as your example 6. So let me go like this. This is period 6, example 6. You're going to do this. You're going to do this question right here. dx over 16 plus x squared. This is period 6 is going to do that right now. Let me switch over and just talk about my example 5, which is what period 6 is working on right now. Hopefully that made some sense. Bottom line is, if you don't have this in your notes, you should be copying it right now. Okay, so the main idea here is we have 3 basic antiderivative rules and we got the negatives of those. So this right here looks kind of like an inverse tangent. If you didn't have the 6 there and you just had a 1, that would be perfect. We do have a 16 though, so we got to get rid of that 16. So we factor out a 16. You've seen that before. We did that last class. So now when we factor out the 16, it leaves a 1 inside, which is perfection. And then we have an x squared divided by 16. You can double check, distribute, perfect, distribute, perfect. From there, that 16 is not in a square root, so you can just get it outside, move it out there. Now you've got your dx over 1 plus something squared. We're going to now transform our x squared over 16 into x over 4 quantity squared. Having that done, I now can see that u would be a good choice as x over 4. Let me get rid of this little thing here. All right, so I like the idea of x over 4 there because that would make this a 1 plus u squared. You can see it right here. So x over 4, also known as 1 over 4x, you take the derivative, you get 1/4 dx. You move the 1/4 over because we don't have a 1/4. Now you can mess around with the coefficients and say, well, I kind of have a 1/4, I just need another 4 on the bottom. Or you can do what I did, which is move the 1/4 over, make it a 4 du, change dx to a 4 du. The 4 joins the 1/16 that was already out on the front porch. You reduce those, you get a 1/4. You get your formula, arctan of u plus c, and then change your u back to x over 4. So 6th period, you were copying that down. If you need a moment to finish copying that down, why don't you ask to pause it. If you're ready, we can just keep moving. So now, my new example 6 for period 4 is going to be the following. dx over 1 plus 16x squared. So now 6th period, you guys get to chill and just check this out as I work through it, because you already have this one in your notes. So, all right, and 2nd period, you can just follow along, or you can ask to fast forward if you guys don't need to see this. Your choice. All right, I have a 1 where I want it. I do not want a 16 here. So what I'm going to do is recognize that that 16x squared is a something squared, and that something would be a 4x. And this is where I make my stupid joke about, do you know what I see? U equals 4x. I think it's pretty obvious. We've done enough of these. du equals 4 dx. I do not have a 4 dx, so I'm going to move the 4 over with division, or multiply by 1/4. So dx will be replaced by 1/4 du. And we'll go ahead and put the du inside and the 1/4 outside. And let me just pause right now for a quick second and say, hey, how are you guys? Good, good, good. Oh, I'm good. I'm good. I'm good, yeah. Awesome. Talking to nobody, but it's cool. All right, let's get back to it. 1/4 du takes the place of the dx. Next, I've got a 1 plus u squared. 4x became a u, and we're looking good. The stuff from the integral to the right, that's your formula right there. So that's going to be a 1/4 arctan or inverse tangent, your choice. And then that's of u plus c. And then go ahead and swap out the u. Change it back to a 4x. And then box it up. It is good to go. Okay, if you want to, you can rewrite that as, oops, an arctan of 4x, and then there's a plus c at the end. Either one of those, totally fine. Please start using them interchangeably. That means sometimes write this. Next time you do one of these, maybe write that. Okay. Next, we're moving on to our third. Let's see. I think I have one more that had a 16 in it. Let me see if I can find it. Found it. Here it is. My example 7. This will be the last one that period 2 does not have to copy down because you guys already did it. So maybe you already fast forwarded through it. Who knows? So we talked about moving the 9s around, right? We joked about inverse signs with 9s. Now we're looking at 16s and tangents. That doesn't rhyme, but who cares? The point is, the 16 that you're dealing with, you're trying to memorize some formula. It's just going to move around. So it's kind of hard to, pinpoint one specific formula. So you might get things mixed up. So my thought is just know the algebra, and you can get through any one of these. That's my goal for you, is just know how to get through any one of these. I'd like this to be a 1 right here. So that means I would not subtract 15, but I would divide by 16 or factor out a 16. That leaves a 1 inside. But what's over here? Go ahead and say it. Yes, x squared. Perfect. And I don't know if you're seeing how beautiful this is, but that 16, that can come out front. Now it's a 1/16, remember, because it's on the bottom. But inside, look at that. That's the formula, straight up arctangent right there. So we get 1/16 arctan, I'm going to go old school this time, of x plus c. And there was never a u substitution, so honestly, we're done with that one as is. I'll go right the other way now. Inverse tan of x plus c. Both are fine. Now on your homework, I don't need you to write both answers every time, but occasionally write this style and occasionally write that style. All right, there we go for our 16s. I think we might be done with the 16s. Maybe. Yeah, I think I can skip that one. That's easy enough. Okay, switching it up. Next up, number 8. How are we gonna deal with this? Dx over something plus x squared. I know what you want to see right here. Do you think you're going to see what you want to see right there? No. Or yes. Is that what you want? I mean, tell me what you want. What you really, really want. Okay, I know it's a 1, but I'm going to put a 7 here. That stinks, right? So, can we still do this? Is this similar to something we've done before? It's kind of like this 16 plus x squared right here. But what was special about the 16 is it's a perfect square. Here, not a perfect square. But it's cool. I can handle it. I still want a what right here? Yes, I want a 1. So I'm going to factor out a 7. That leaves 1 plus x squared divided... Wait, let me see here. What is x squared divided by 7? I just said it. X squared divided by 7. Perfect. So that means I could put the 1/7 out front. I can leave the dx on the top. And I can leave on the bottom 1 plus something squared. This is where it's a little different. X for sure on the top because x squared is x squared. But what do you square to get a 7? Turns out it's a square root or radical 7. So that means our u sub is going to be x over rad 7, also known as 1 over rad 7x. So then du would be 1 over rad 7 dx. And I don't have a 1 over rad 7 dx, so I'm going to go ahead and move that over here. We'll call that a rad 7 du equals dx. I simply multiply both sides there. If you can't see it, I just multiply both sides. Let me do this like this in red pen. Times rad 7, cancel, cancel, times rad 7. Oops, should put the times on this side. There we go. So now when I see a dx, I can change it to rad 7 du. So I've got a 1 over 7 times rad 7 du, and on the bottom 1 plus u squared. We're pretty much done. We'll just go inverse tangent of u plus c. You notice I just multiplied the rad 7 times the 1/7. So that's rad 7 over 7 inverse tan of x over rad 7 plus c. And that's great. That's a great final answer. But there's a formula that you're going to see later. It might be helpful to see this. This is the same as 1 over rad 7. Let me prove it to you real quick. Trust it for a second and then say, hey, wait a minute. You can't just like change stuff like that. Like, what's up with that, bro? Well, how about this? If you had this and somebody said don't leave a radical on the bottom, wouldn't you multiply top and bottom by a rad 7? So picture this, rad 7. On the top you get a rad 7. On the bottom you get a 7. Right? So you can see it right there. You can also just divide this by rad 7, divide this by rad 7, and that'll do the same thing. All right. So we got a couple different forms of that answer. I'm kind of digging this one right here. So I like that style a little bit better. All right, I'm going to need to turn the page. I don't know if you need to turn the page. We need about 5 or 6 lines for the next one. We're switching it up. We're going to a different look. So hopefully you got space, because you left space like we did last time, like we talked about. And I'm on example 9. And feel free to ask for a quick break if you need one. If you want to keep going, we've got a few more of these. It looks like a 9, 10, and 11. So if you want to just power through them, fine by me. I'm going to, because I want to go home soon. All right. Next up, I've got this integral of dx over x times the square root of x squared minus 9. All right. And if you remember our formulas from the other day, this does not look like inverse sine. This does not look like inverse tangent. The only one left would be inverse secant. So you want to see a minus 1 inside there. So x squared minus 1 would be beautiful with an x out front. I have the x out front. I do not have the 1 in here. But never fear. Algebra is here. We're going to make it happen. Okay. Oops, I should have left a little space there. Well, I'll do it on the next step. I need to get rid of that 9 right there, which means I need to divide out a 9. So I'm going to go like this. That'll get me my minus 1 over there. In other words, 9 times negative 1 is negative 9. Now, what's x squared divided by 9? Because that's what I have to do here. I know. I just said it. I gave it away. Shame on me. Let me zoom in a little bit so you can see it a little bit better. There we go. I don't know if you can see where we're headed with this, but what's the square root of 9? 3 comes out. Next, inside, we're going to change that x squared over 9 into a parentheses squared, and then we get your minus 1. So then it's time for you to think of what would you square to get an x squared over 9, and that would be x over 3. And there you go. Get it? Do you get it? All right, next up, du is equal to 1/3 dx. Oh, do you see it? Do you see what I see? Look at that. It's beautiful. You got a dx on the top, you got a 3 on the bottom, and I feel like a fool right now because I'm looking across the room and there's nobody here, and I'm singing to myself. Whatever. Next, that 1/3 dx changes to a simple du. Down here on the bottom, uh-oh, I don't know what to do with that x. Let's leave it for a minute. Let's leave it. Skip that part. Pretend like it's not there. We'll come back to it. And inside the radical, what are we going to have, y'all? 1, 2, 3, go. Yes. U squared minus 1. If you didn't say that, then I guess technically it's a no. Don't do that. But we need that. Okay, so this x, I have to replace x, though. I replaced the dx over 3. I replaced the x over 3 quantity squared minus 1. But this x right here, that x, we need to do something with that. Let me highlight that little x, because if we forget about it, we just ruin this, and we don't want to ruin this. So here's what we're going to do. I'm going to take this formula right here, and I'm going to solve this for x. That means I'm going to go multiply both sides by 3. and I'll get 3u equals x. So x is equivalent to 3u. So x is 3u. All right, so a little sneaky there, but we got it. We're back on track. So I've got a 1/3 out front. I've got a du over u times the u squared minus 1 in a radical. This is straight up formula. So that's going to be arc secant or inverse secant of u plus c. So that'll be 1/3 inverse secant of the stuff, which is x over 3 plus c. And then we box it up. So there you have it. Let me zoom out a tiny bit so you can see the whole thing. Now again, we're looking for shortcuts. So as you're doing these on the worksheet for part of your assignment, you'll be looking for all the hard work on your regular paper, and then you're going to transfer all your answers, straight up simple answers, as simple as can be, onto the worksheet so we can hopefully just see some nice clean patterns. All right, let's keep on going. If you need to pause it, you can do that. We've got 2 more. Here we go. Example 10. You think you know what you're doing? And then along comes a 20, not 5, but 29. Everybody say, ew. I agree. I don't like the 29. But you know what? We dealt with the 7 earlier. We can deal with the 29 right now. So here goes. I'm going to go ahead and factor out a 29 right here. I'm going to move quickly here. This is x squared over 29 minus 1. Next. Square root of 29 is going to come out front. We'll leave the x. Inside here, I'm going to have x over rad 29, kind of like we did our x over rad 7 earlier. So I just transform x squared over 29 into something quantity squared. Okay, so from here, u would equal the x over rad 29, which is 1 over rad 29x. So du will be now 1 over rad 29 dx, which again is beautiful. We have that right here. But now we're going to do that same trick where you have to get the rad 29 away from the x side, because I have to replace the x now. So let me shorten this up a little bit here. What we have now is dx over rad 29 can be replaced with a du. The x can be replaced with a rad 29u, and if you catch it right away, you can just stick the rad 29 out front in the bottom of a fraction, 1 over rad 29. All right, next, inside here you had a stuff squared minus 1, which is u squared minus 1. So I'm going to go ahead and picture this outside and just go 1 over rad 29. Just pretend like it's not there because I factored it out front. And then we've got arc secant. I'm going to go old school this time just to mix it up a little bit. Don't use the -1 up there anymore if you do the arc secant, and then of u plus c. And that turns into 1 over rad 29 arc secant of the stuff, which is x over rad 29 m plus c. I don't know, maybe you're seeing it, maybe you're not. Again, doing this work wholeheartedly on your paper, doing all the algebra, and then we will do another one of these worksheets. So we're going to do this worksheet full out. So like, do all the work and then put the answers on your worksheet.